Now I want to revisit that city population problem that we did in the last video, but I want to give you some actual numbers and then go doing it a different way using the natural logarithm, natural exponential function, and you will see how I do that. And I'm going to now be using the inverse function, the logarithm function, to get my answer. I've written my little cheat sheet here that I'm going to refer to because my camera is my calculator. So watch this. First of all, you recall that we showed that P of 40 was 5,000 times 2 to the 40 over 15 power, which was equal to 5,000 times 2 to the 8/3. I type in 8, or in my calculator, 8 divided by 3. I then take 2 to that power, and then I multiply times 5,000, and I get 31,733.35. Now, I want you to be very careful to use your heads on this. Does it make sense to talk about 35/100ths of a person? Doesn't. So we round down and we say 31,733. Now in this, 8/3 is 2.666 ... It just goes on and on and on. I stopped at 3 decimal places, and you're going to see that this number changes the more accurate or the more precise you are with this. As you go many decimal places out, you're going to get a slightly different number. But 31,700 something is going to be the population of this city, if it indeed doubles every 15 years. Now, that was in base 2. For our exponential function in base E, it goes a little bit differently. My population, P of x, is going to equal my initial population. I'm going to subscript it with a 0, P0, times e to the kt. K is some constant that I need to solve for. T is time. So in my case, I have, make that a t. P of t is that. So now I want to know, I know that my population doubles in 15 years. So P of 15, if I start at 5,000, what's my population going to be in 15 years? It doubles every 15 years. My population is going to be 10,000. It's doubled. 10,000 is equal to my initial population, which is 5,000, times e to the some constant that I need to solve for times 15. 15 is the number of years. So let's now figure this out. I'm going to divide both sides by 5,000, and I get, let me draw an arrow here, 2 is equal to e to the k times 15. Now you're wondering, how do I solve for this? How do I get k? It's an exponent. This is where I use my inverse function to figure that out. I'm going to take the natural log of both sides. If these guys are equal, their logarithms will be equal. So I take the natural log, ln of 2, and I set it equal to the natural log of e to the k times 15. And if you remember from the rule of logs, the natural log of e to this is k times 15. So I have that the logarithm of 2, the natural log of 2, is equal to, I'll write 15k. I'm going to divide both sides by 15. And I get that k is equal to 0.0462. I'm going to stop at 4 decimal places, but I could go on and on because this number really does go on and on. Logarithms are rarely integers. So let me give myself some room. Remember that our population density when we did the doubling was 31,733. Okay, so we expect to get an answer close to that. So I found that K is 0.0462. So I now have my equation P of T is equal to 5,000 times E to the 0.0462 T. And now I'm going to find out what it is for 40. So let's do that. I'm going to put a 40 in the slot, and I'm going to put a 40 right here. And when I do that calculation, I get 5,000 times E to the 0.04, well, I just, when I do this basically I'm going to do this calculation, multiply these two numbers together, take E to the X, and then take that number and multiply it by 5,000, and this time I get 31,748.02. Again, it makes no sense to talk about 2/100ths of a person. We round down, and I get 31748. Now you may be thinking, well, that's not as close, or that's not the same number as this, but it's close. And again, the reason we're having any difference at all is because of rounding. I could have taken 0.0462 a lot further out. Back when I did the doubling one, I could have taken 2.666666 and gone on and on and on, and I would have gotten numbers that were much closer together. But I'm satisfied. I have shown that the population of this town is going to be about 31,700 something. That's good.